Hello, scholars. Today we're going to talk more about intermolecular forces. And so we want to be able to identify what types of interactions, and there's three types we're going to talk about here: London dispersion forces, dipole-dipole interactions, and hydrogen bonds will occur between two molecules. And we want to be able to rank the bonds that we talked about previously, covalent and ionic, and these interactions in order of strength in solution. So basically, how easy will it be for them to get pulled apart and dissolve in solution in water? So first of all, I want you to kind of take a second to predict how would two polar molecules attract to each other. You might guess that because opposite charges attract, the negative end of one molecule will attract the positive end of another molecule. And these are called dipole-dipole interactions. And intermolecular means between molecules. So these are attractions that are going to form between two polar molecules. And we call these dipole-dipole interactions because this molecule has a dipole, it's polar, and this molecule has a dipole, it's polar. And so these kind of attractions are not as strong as ionic attractions because remember, these are partial charges, but they're going to happen anytime you have two polar molecules in solution. Hydrogen bonds are just a special case of these dipole-dipole interactions. They're really strong dipole-dipole interactions. In order to form these hydrogen bonds, you have to have two molecules that contain an OH, an NH, or an FH bond. Oxygen, nitrogen, and fluorine are the three most electronegative elements on the periodic table. And so when they're bonded with hydrogen, they're going to be very, very polar. And so they're just going to have an extra strong dipole and an extra strong dipole-dipole interaction. We call those hydrogen bonds. So the hydrogen will always be partially positive and it will always attract to that negative oxygen, nitrogen, or fluorine end of another molecule. Lastly, we have what we call London dispersion forces. Even nonpolar molecules are able to attract to each other and to polar molecules through these London dispersion forces. And so remember that the electrons are constantly moving around the nucleus. Every once in a while, the more electrons might end up on one side of the nucleus than the other. And so we'll have a very temporary dipole where one end of the atom or molecule is partially negative and the other end will be partially positive. And when that happens, the electrons in the atom or molecule next to it will be a little bit more attracted to that partial positive end of the other atom or molecule, and you'll get a temporary dipole in the other atom or molecule. And so for a very brief moment in time, those molecules will be attracted to each other. They'll have those temporary partial charges, and that will attract them to each other. So to kind of summarize the strength of those attractions, the weakest one of the intermolecular attractions are the London dispersion forces between nonpolar and nonpolar molecules. Those are going to be temporary and easy to break. The next strongest are going to be polar and polar molecules. They can form not only dipole-dipole interactions with each other, but also London dispersion forces with any other molecule. And then lastly, the strongest intermolecular attraction are going to be our hydrogen bonds, the attractions between two molecules that have very polar bonds in them, that OH, NH, or FH bond, to another molecule with an OH, NH, or FH bond, because they can form not just hydrogen bonds, but also dipole-dipole interactions with other polar molecules and London dispersion forces with any atom or molecule, even if it's nonpolar. And so we're going to do a lab at the end of this unit, but even though there's some attraction between polar and nonpolar molecules, because all atoms and molecules can form London dispersion forces with each other, polar molecules don't mix well with nonpolar because the polar molecules have a stronger attraction to themselves than they do to the nonpolar molecules. So it's just something to keep in mind for later. Take some time to rank the following bonds and attractions from weakest to strongest in solution. and make sure you can explain what's happening or how each one of these forms. So to summarize the types of forces and the strength of their attraction, we're going to start and go from weakest to strongest. So the weakest attraction that can happen between molecules is the London dispersion forces, and these can happen between any two molecules or really any two atoms because of temporary dipoles. Electrons just happen to be more on one side of the nucleus than the other and create very slight and very temporary partial negative and partial positive poles. The next strongest is our dipole-dipole interactions. And these can happen between any two polar molecules. You have a negative end of one molecule attracting to a positive end of another molecule or vice versa. Again, those are a little bit more stronger because those dipoles are permanent. The next strongest are our hydrogen bonds. Remember, they're really just a special case of dipole-dipole interactions that happen between any two very polar molecules. And to be very polar, they would have to contain an NH, an OH, or an FH bond. Getting into the intramolecular bonds, we have then the ionic bonds. These are going to be stronger because they're happening between two fully charged ions that have completely transferred their valence electrons, so complete positive, complete negative charges. And lastly, water is not able easily to break apart covalent bonds. And remember, these are happening between bonds in the same molecule that are sharing their valence electrons between them, sometimes more or less unequally, but are attracted to each other because they're passing back and forth shared electrons. And so, again, these first three are the intermolecular forces that are happening between molecules, and these are the intramolecular forces that are happening within substances themselves. So, hopefully, if you have any questions, let me know. And remember, if you're learning, you are winning.